Hey Stepsters! I'm Lasya.
And I'm Kritika, and we're your trainers from Future Steps.
Today we'll be looking at whole numbers for grades 5 to 7.
Okay, so let's get started. Now, we're going to talk about factors and multiples first. So let's start off with factors. We know that 1 is a factor of everything. Every number can be multiplied by 1 and divided by 1. And it will give the same number either way. And then every number is a factor of itself. So we know that, and then a factor is always either less than or equal to the number itself. It's never greater than. If it's greater than or equal to, then it's going to be a multiple and not a factor. And then the numbers of factors for any number is always infinite, so there can be infinite numbers of factors. Now moving on to multiples. Multiples, like I said, are always greater than or equal to the number itself. And there are also infinite numbers of multiples, since there are infinite numbers of factors. And then to verify a multiple, you can just look at the numbers table. So if we're looking at the table of twos, to see if the multiple that we found is correct, we can just go ahead and look at the table and say, oh, it exists on the table, it's there. So then that's correct. Now let's look at an example. So we have 5 times 6 equals 30. Now what do factors mean is the factors of in this expression would be 5 and 6. These are factors. So a factor would be something that you multiply. And then the result that comes out is a multiple. Pretty simple, decent, right? So let's look at this. In the table of 2, the factors of 2 will be anything that we multiply to 2. So 2 times 1, 2 times 2, 2 times 3, 2 times 4. Over here, 1, 2, 3, and 4 are all factors of 2, right? And then 2, 4, 6, and 8, which are all the results from it, are all multiples. The same thing goes for the table of 8. Whatever we multiply 8 by are all the factors of 8. Again, kind of went over that, but. And then all the multiples are the result. So if this was the table of 5, then a factor of 5 would be 6. If this was the table of 6, a factor of 6 would be 5. And pretty simple, it goes the same for every table. So you can always just look at the table and find the factors and multiples.
Now let's look at order of operations. So these are basically the order you go in or follow whenever you're like multiplying or dividing many numbers like that, or subtracting or adding many numbers in this format. So they're basically two different forms, they're two different names, but you can use any one of them. They both actually do the same thing. So let's go for PEMDAS first. So P starts with parentheses. That means everything in a bracket goes first. So you do everything in a bracket first. And then E is exponent. So let's say you have a bracket and then you have an exponent in it. Then you do the exponent first. And if you don't have a bracket first and then you have an exponent in the equation, then you do the exponent first. Because you don't have a bracket in front of it, right? And then M is multiplication. So after exponent, it's multiplication, then division for D, addition for A, and subtraction. Subtraction is the really last thing you do in the orders of operations. Same for BODMAS. BODMAS, right? B for brackets, O for order. It basically means exponents. It's another word for exponent. D for division, M for multiplication, addition, and subtraction. That's the order you do them, first and the last. Okay, let's look at an example now to get a better understanding of how to use this actually in problems. So in this case, we have 11 multiplied by open bracket 5 squared plus 3 close bracket minus 5. So according to these, you always start with the bracket first. So in this case, it's this. So let's do this first. So first you start with the exponent, right? Because that's next up in the order. So, and in this case, it's 5 squared, which is 25. And then you add, right? That's next up in the order in the bracket. So you add 3, which is 28. Next, let's look at the order. We have a subtraction and we have a multiplication. What comes first? Multiplication, right? So you multiply your answer from the bracket with the number you're multiplying with. So in this case, it's 28 multiplied by 11, which gives you 308. And finally, what's the last thing you gotta do? Is minus 5, because that's the last in the order, right? So you just minus 5, subtract 5, and your answer would be 303. Right? And that's your answer. Now let's look at the second question. In this case, we have a big number in the bracket. So you always start with the bracket, and then you do exponents first. So in this case, it's 144, and then you can add first, right? Addition is before subtraction. So add 17, which is, it's, I think it's that, hopefully. And then you subtract 50. And the answer you get, whatever answer you get, you just multiply it by 16. Remember, it's 146. Oh, the final answer is 146. And then you get 146 as your answer after doing everything in the bracket. So everything here, even if it's like, addition and subtraction and you have multiplication outside, you first need to be done with your bracket and then go to anything outside of your bracket and look at the order again. So in this case, it's multiplying by 16, and your final answer would be 2,336. And yeah, that's it for order of operations. And then you can look at the next topic now.
So now we're going to talk about ratios and proportions. So let's look at these questions first. Now, how do we use ratios to find the value of an unknown number? So here our unknown number is a. We're trying to find the value of a. So there are two ways you could do this. Either you could multiply both sides by 7 over 7, or you could just do a method called, but I don't know if you guys call it cross multiplication or butterfly, because either way it's the same thing. So we could just look at this and we can multiply both of them. So that will make us get 7a equals 10. So a would just be 10 over 7, which is just 4.1, I'm pretty sure. Or 1.4, sorry. I wrote it the other way. 1.4. And mostly you don't have to write it in the decimal version, but I'm just having that as, you can also write it that way. Now let's look at number 2. We're trying to find c. So here let's look at here. This method is what I find easier, but if you guys find the multiplying both sides easier, then you can do that too. So when you do this, you get 3c equals 53.3. Then c would be 53.3 over 3. Now, since there's a decimal in the fraction, we would prefer you simplify it rather than keeping it this way. And when I say simplify, you just write in its decimal, which is 17.77. So that is how you do this. And if you want to know how to do the other way, that would just be this thing. If we multiply this by 7 over 7 on both sides, that would just get a over 35 equals 2 over 7. And then you can simplify it that way too. But I find this way easier. If you want to learn the other way too, you can comment down below and I can teach you that. If not, then this is ratios and proportions, the easiest way.
Okay, now let's take a look at prime and composite numbers. So these are really easy. It's basically prime numbers has exactly 2 factors, so it's 1 and itself. That's it, nothing else. And you know what factors are, right? So examples would be 3, 5, and 7. So why wouldn't 3 be a prime number? It's because the factors of 3, if you look at it, it's just going to be 1 and 3, right? That's it. Nothing else multiplies with something else to give out 3, right? Like 2 times 1, it's 2. 2 times any number or any other number times another number never gives you 3 except for 1 times 3 and 3 times 1. That's why 3, and same for 5 and 7, and there are many other numbers too that go on for like infinity. Those are prime numbers, okay? And then composite numbers are the exact like opposite of that. Basically, they have more than 2 factors in this case. So for example, it could be 9, 10, 12, 14. Many numbers are composite numbers. So let's take 10 in this case, okay? 10, the factors are, or let me write them like a little far away so that, because 10 has quite a few factors to it. It's 1, and the way I do this is this. I put 1, and then what else? What times 1 gives you 10? It's 10. So just put 10 at the end and a comma. And then 2, it works, right? 2 and 5, right? And then 3, no, you go on, and nothing else. So it's just going to be 1, 2, 5, and 10. Those are the factors for 10, and it's more than 2, right? That's why 10 is a composite number. Same for 12, 14, and so on. And that's it for prime and composite numbers. Yes, they're really, really free and really easy. Now, let's take a look at the next topic.
Okay, so now we're going to talk about LCM and GCM. So what is LCM? LCM it stands for least common multiple. So the name itself gives you what it is. It's the lowest common multiple between two numbers. And then GCF is the greatest common factor. That also gives you itself in its name. So greatest common factor is the biggest and common factor between two numbers. So let's look at an example. So we have example 1, which is find the GCF of 24 and 36. So first we wrote, and we know that GCF is greatest common factor. So we wrote down all the factors, or a lot of the factors of 24 and 36, because remember, factors, they're infinite numbers, right? So we wrote down a couple factors, and we were asked to find the greatest common factor between these. So if you look at this, they have a lot of common stuff. So they have 1 and 1, 2 and 2, 3 and 3, 4 and 4, 6 and 6, and then 12 and 12. They asked us to find the GCF, which is the greatest. So out of all of these, the greatest would be 12 and would be 12. So the answer to this would be 12. Now, if we look at the second example, which is find the LCM of 3 and 5, which is the lowest common multiple, we're just going to look at this and do the exact same thing. So we have a couple of the multiples written down, because remember, we have infinite and we only want to look at the ones they have given us. So when you look at this, we just have to see and go, okay, what do these two have in common? So there's 15 and 15. Is there anything else? No. So in this entire thing, the lowest common multiple, well, since we only have one, it would be 15. But if we had another, then it would be whichever number is smaller. So here the answer would be 15. So pretty simple, just remember that LCM means least common multiple and GCF means least common factor, and GCF means greatest common factor. Okay, wait. LCM means least common multiple and GCF means greatest common factor. Just remember that. Okay? If you have that in your mind, then any question that says GCF or LCM will be pretty easy because you know which one is least and which one is greatest.
Now let's look at divisibility rules. These are really helpful, in my opinion, because you would know a number just by looking at it. You would know what numbers it could be divisible by, and that's really important as you like go into higher grades, like in high school. So for 2, if a number ends with 0 or an even number, then it's divisible by 2. So basically, let's take 10 for example, right? 10 ends with a 0, so it is divisible by 2. Let's take 12. 12 is an even number, so it is divisible by 2. And for 3, it's sum of the numbers need to be divisible by 3. So basically, let's see, what can I take? Okay, 15, okay? 15, 1.5 is 6, right? And is 6 divisible by 3? Yes. 6 divided by 3 is 2, right? So that means 3 is divisible, 15 is divisible by 3, right? And we know the answer, right? It's 5. So basically, these are numbers. The example I just gave you is a small number, but then you can use this trick for like big numbers, like really big numbers those are in thousands, even millions, and they will still be true. These divisibility rules will apply for them too. And then for 4, the last two digits need to be divisible by 4. So what I mean by this is, let's take what can I take for this? Maybe 524, right? And 24 is divisible by 4, right? And that's why this whole big number, right, is divisible by 4. You can just look at it and say it now that you know that if the two last digit numbers are divisible by 4, the whole entire number is divisible by 4. And then for 5, it needs to end with 5 or 0. You know that, like 5 times, let's take 15 again. 5 is a 5, right? So it is going to be divisible by 5. Or like 100, it has a 0 at the end, and it is a 0, so it is divisible by 5. And then we have 6. So for 6, it should either be even and it should be divisible by 3. So basically, let's take 36, right? 36 is an even number. And remember, n means it should be both of them, okay? It cannot be only even and, oh, it's divisible by 6. No, it should be even and be divisible by 3. So if you divide this by 3, you get 12. So it is divisible by 6 in this case. And it's simple, it's just 6, right? 6 times 6 is 36. But then again, if you take larger numbers, these rules are really useful. And then let's see, 7 is 2 times the last digit. Subtract that number from the other digits. And the result must be divisible by 7. I know this sounds really complicated, but let's look at an example and see how easier. So basically, you have 651, right? Divided is divisible by 7 or not? That's the question here. So you take the last digit. In this case, it's 1. So you say 1 multiplied by 2, and then you subtract that from the first two numbers or the first few set of numbers. So in this case, it's 65. So it's 65 minus 3, minus 2, which is 63. And you know that 7 times 9 is 63. So this is true, and 651 will be divisible by 7. Then we have 8. So the last 3 digits need to be divisible by 8. Of course, I don't have an example for this, but just know that if the last 3 digits are divisible by 8, it combined, not like separately. Like if you, in this case, there are 3 digits, right? Let's just take 156.7, right? All of this needs to be divisible by 8, not the individual ones. Like 5, is it divisible by 8? Of course not, right? Let's look at all of them in a whole group and see if it's divisible by 8. And then we have 9. That means sum of digits is divisible by 9. So, can I take for it? Right, 63. I'm taking a small number again. So like 6 plus 3 is 9, right? And 9 is divisible by 9. So it is 63 is divisible by 9. And then last rule for today is 10, which ends in a zero, of course, right? 10 times anything will always end in a zero. And that's it for divisibility rule.
Okay, so we learned everything about whole numbers, all of the rules, all of the we did questions on everything. So all I need to tell you guys is continue practicing, do more questions, and don't make my mistake and think of this as least common factor. It's least common multiple. And we will put pictures of the factors and multiples and the divisibility rules so you don't have to go back and then take a screenshot. We can put in a picture of that at the end of the video. And so keep practicing, do more problems, have some fun. Math is always fun. And you guys got this. So that's all we have for you today. Comment down any questions, concerns, video requests, anything at all. We do look at all of our comments, so we will look at yours. So that is all we have for you today. See you in our next video then. Goodbye.
Bye, sister.